So for the last part of this section, looking at the three different types of quadratic equations, we have the standard form, the vertex form, and now we're going to look at the factored or zeros form, which is the a times x minus r, x minus t, both in parentheses. And so just to start here, we're going to do some factoring. So in the past, we've worked with things like this, complex trinomial, and we've been able to factor that. So just a little factoring review. If we have 4x squared plus 15x plus 9, and we want to factor that, we start off by multiplying the coefficients on the first and last terms. So 4 times 9, which is going to give us 36, positive 36. So now we need to find a pair of numbers that multiply to 36 and add to 15. So numbers that multiply to 36, 1 and 36, 2 and 18, not quite there yet, 3 and 12. All right, there, 3 plus 12 is 15, 3 times 12 is 36. This is our pair of numbers that we can rewrite this expression with. 4x squared plus 3x plus 12x plus 9. Remember, you can flip these around and have the 12x first and the 3x second. It's just going to change what the next step looks like, but the final answer will still be the same pair of binomials. So we common factor the first pair. So 4x squared plus 3x, so the common factor there is just x. We're left with 4x plus 3. And then bringing down this same sign here, so it's going to be a positive. And the common factor between 12x and 9 is going to be 3. And we're left with 4x plus 3 there. Both our parentheses are the same. They're a common factor in this pairing. And so we have 4x plus 3 and x plus 3. In the next example, we have 6x squared plus 21x plus 15. All these numbers are multiples of 3. So we can actually common factor out a 3 from here and then be left with 2x squared plus 7x plus 5. Then we can factor this portion here out and get our final answer. So we have our 3 and then 2x squared. Two numbers are going to multiply to 10 and add to 7 are going to be 2 and 5. So plus 2x plus 5x plus 5. And then we'll do our common factoring. 2x from the first pair, we're going to be left with x plus 1 plus 5x plus 1. And then we common factor out that last bit there, and we're left with 3x plus 1 and 2x plus 5 as our trinomial. That there, this situation here, this is here. That's our factored form of the quadratic equation. There's our a value of 3, meaning this is opening up with a stretch. And then these will provide us with our 0 values. Now, we're not going to quite look at the 2 portion here yet. We'll look at that in a later lesson. But we can find our values from here. So here we have the standard setup for our zeros or factored form. A, x minus r, x minus t. R and t are just numbers. Your textbook, I believe, uses s and r. I don't use the s because my s's sometimes look like 5s. It doesn't matter what the actual letters are. It's just that they are 2 letters representing the missing variable. So looking at this, A again is still our direction of opening that never changes. So it's going to have the direction of opening in a vertical stretch or compression. The X-intercepts are roots. Now these are the points where the graph is crossing the x-axis. These are r and t. So that's the points where the graph crosses the x-axis. In this section here, we're just going to look at situations where we do have something actually hitting the x-axis and crossing the x-axis. We're not going to take into account the situations where it doesn't. We'll look at that again later. Do note, though, that the signs of r and t are opposite the bracket. So I have a positive r, positive t. They're negative r, negative t here. Just like our vertex form, the number in the bracket with the x, we always use the opposite sign when we're actually graphing it. The x-coordinate of the vertex, so we can find the h value here. We can find this h value by, so this equals h. We can take the r and t values, add them together, divide by 2. We can take the average of these 2 points, and that will find us the middle, and that's the h value. Because this graph is symmetrical, the zeros will be equally spaced from each other. So that's the double dash here. I could use a single dash. I thought the double dash stood out more. So we have this length from here to the axis of symmetry is the same as this length from the axis of symmetry to the t. It's always going to be the same. So you can take this plus this, divide it by 2, you will get h. Even if you have a positive and negative number or 2 negative numbers, the addition of those 2 values divided by 2 will give you the h, the x value of the vertex, and also give you the value for the axis of symmetry. Do you recall again that the vertex is that point, and keep this frame, the vertex is the point where it changes direction, so either goes from going up to going down, or in the case of the opposite type of graph, going down to going up. The axis of symmetry, again, is that line that cuts the graph into 2 equal parts. It is making the graph symmetrical about that line. If you, again, recall the red mirrors from elementary school, you would put the red mirror on that line there, and it would have mirrored the graph on either side. So now working with this, a little bit of application of it. If you're given an equation like y equals x plus 6 times x plus 10, and you want to find the vertex of this. So we said that the vertex is at the average of these, the middle of these 2 points. So the h value of the vertex is equal to positive 6, no, negative 6. Why? This is in the brackets, so whenever we pull it out of the brackets, it becomes opposite. That's why we use the x minus r, x minus t. So the opposite sign, negative 6, plus 10, positive 10. Okay, so we're adding positive 10 to the negative 6, and then we're going to divide that by 2. That will give us a value for h. Negative 6 plus 10 is going to be negative 4, or sorry, positive 4, divided by 2. Positive 4 divided by 2 is going to be 2. So the x value of the vertex, that's the x value of the vertex, that's going to be 2. Okay. Now if we want to find the y value, well, this is our x value here. I know we use the letter h because we're working with the vertex, but if we put a value in there for x, the 2 in for x, that will let us find the y value of the vertex, or the k. So our k value of the vertex equals 2 plus 6 times 2 minus 10. So the k value, 2 plus 6, is going to be 8 times 2 minus 10, which is going to be negative 8. And our k value is going to be 8 times negative 8, or negative 64. So 2 and negative 64 becomes the vertex of this graph. So again, note, the signs change. Negative 6 from the positive 6, positive 10 from the negative 10. The signs flip around to get the values. Next part here, determine the equation of the following graph in factored form. So we want it take this graph, this information we're given, to x-intercepts at 5 and 15, and a point at 12 and negative 63, and we want to find the equation in factored form. So our equation in factored form will be y equals ax minus r x minus t. Well, what are we given? Well, we have here r and t, and we have x and y. So we're given r is 5, or given t is 15, or vice versa. And then we have our xy. So we can fill in y, x, r, x, and t, and be left with a, one variable, and we can solve this. So let's fill all that in. Negative 63 equals a, 12 minus 5 times 12 minus 15. Working through that, 12 minus 5 is 7. 12 minus 15 is going to result in a negative 3. 7 times negative 3 is going to be negative 21. We can write that in front of the a if we want. We're used to doing that. Negative 21a. And then we need to divide both sides by 21. So 63 negative divided by negative 21 equals a. 63 divided by 21 is going to be 3. And that's our a value. Therefore, y equals 3, x minus 5, x minus 15 is the equation. Again, noting positive 5 here, positive 15 here, negative 5 in the brackets, negative 15 in the brackets. Whenever we put those numbers in the brackets, we're going to get the opposite type of situation. So, some problems you can look at from section 4.5. So from 4.5, some good questions. Number 1. Number 3. Let's do B and C. Those look like good ones. Number 4A. I note this one's got a little sneaky thing. Remember, if there's no number in the brackets, that it is 0. Let's see, number 5 looks good. Number 7 and number 10. So 1, 3B, C, 4A, 5, 7, and 10. Check those ones out. And that'll about wrap up this general look at the 3 forms of the quadratic equation. And then we can get ready to look at some review of this.